All right then. So hello everyone, and thank you for joining me today. First, quick introduction. My name is Amir Golan. I'm product manager in Spot by NetApp, working in the past few years both on compute optimization products, FinOps solutions, and recently focusing with CI/CD. During the last year, we have released Ocean CD, our new product that provides continuous delivery solution for Kubernetes applications, focusing with Canary Deployment. Now, this webinar is actually the first out of a series of webinars on software delivery best practices. And in our agenda today, we will overview market trends and challenges related with application delivery in the modern DevOps organization. What are the solutions to improve efficiency around that? And introduce you with Ocean CD, a Spot by NetApp newly developed solution, bottom-up engineered to solve the most critical challenges of Kubernetes CD using Canary deployment strategy. And maybe most important, a live product demo for you to see how exactly Ocean CD connects all the dots. And I think that we will start with what we as product manager probably like the most, KPIs, key performance indicators. The key to understand the modern CD challenge is to understand first what organizations are trying to achieve. And eventually it comes to that. Be able to fully utilize dev power, release more, provide more value to customers, and do that with minimum production issues. Now, what you're looking at is basically ways to measure these KPIs, and we have 4 metrics that we are looking at. The first one is like how frequent you deploy updates and new features to production, how much time it takes you to release the change. Out of these releases, how many are successful, or more important, how many have failed? And assuming you have failed, how much time it takes to catch it and recover? Now, the recent State of DevOps survey show that 26% of organizations are considered as elite, which means successfully releasing multiple times a day with minimal failures and quick recovery time. But what about the remaining 74% that struggle to improve their software delivery performance? What is blocking them from achieving that? Now, in order to understand that, we need to dive a bit more into the modern cloud trends. And what we see is that as technology allows more, the organization has more considerations to take care of. To start with, we talk with tens of customers that are using or migrating to Kubernetes while trying to break their monolith into microservices. These are welcome changes that provide tools to release more, but it also means that multiple changes can easily occur in parallel and affect each other, which is something that, of course, needs to be carefully monitored and managed. Second, be able to deploy more means adding more automations. It means to add more logic into the process and reduce manual interventions. And last but not least, modern cloud technologies help to shift left responsibility to service owners and developers. And this movement, of course, is welcome. But even more crucial, it allows, especially for organizations where the DevOps and Dev ratio is a bit higher, to allow the developers with more control and service owners with more responsibility and understanding on what is going on. But we need also to ask, does our non-DevOps stakeholders have enough understanding and control on the delivery process in general to take this type of responsibility? And the thing is that since release frequency is growing, and since service owners don't always have the tools, the attention, or even the capability to track the impact of all releases, a new risk has arisen related with the reliability of the deployment process and the quality of the released software changes. The thing with Kubernetes and microservices is that it makes applications and environments more complex to service owners, and it will usually generate a lot of data. So at the end of the day, troubleshooting any type of issue becomes a nightmare, and failures will stay hidden in production or will be discovered when it's too late and when the damage is already done. So basically, here is a possible answer why 74% of organizations are still behind the elite organizations. The reality is that organizations that are trying to release more will have higher probability to fail more. These are the 74% that will consciously choose to release less and have longer release cycles in order to stay in control and have confidence with the process and with the release reliability. And basically by that, the fifth software delivery metric is revealed, which is the reliability of the deployed software. In many cases, it is the lack of reliability that makes organizations that can release more in theory to be less agile and not to fulfill the full R&D and business potential the modern cloud technology has promised. But with that, the good news are that things aren't that bad. Together with advanced cloud technologies, the popularity of progressive deployment strategies like Canary Deployments allows gradual and controlled releases, and this is something that has recently grown significantly. And many organizations we talked with are anxious to implement it. It does not exist out of the box in Kubernetes, but with the right mix of tools and processes, you may be able to achieve it. And as you can see there, the idea is not only to gradually deploy, but also to catch issues in early phases of the release and take the application back to its stable state. So basically, we found the solution, right? The honest answer, not yet, because while being considered as best practice for software release by customers, many of them are still struggling to implement it. This is mainly because defining a Canary strategy is not that intuitive. Each strategy may include many complex queries and conditions that varies between different services. Canary definitions can be long and complex, and while this can be bearable for few services, imagine what happens for multiple services with similar deployment phases that have slight differences, or when the deployment logic needs to be updated over multiple services. And last but not least, the fact that organizations' cloud presence, as it grows, so do data and environment complexity. And according to recent Forrester report that asked how many tools does your organization currently use for monitoring, the average number was 8. Now, just add on top of it traffic tools and Kubernetes events, and you will get maybe the most challenging part of running a progressive delivery process. How do you orchestrate between multiple analysis outcomes, traffic split, and automations? This all means that in order to maintain a robust Canary process, you should have an engine behind scenes, and not just a collection of imperative steps. And that's the exact spot where OceanCD comes in. OceanCD is a continuous delivery product built for Kubernetes applications, and its focus is to make Canary a reality for organizations that ask to provide more control to R&D teams and reduce the DevOps burden. OceanCD is a multi-cluster SaaS, and it takes the popular CNCF open sources like Argo Rollouts as an engine and adds many management capabilities on top of it. OceanCD SaaS basically provides a clear separation between what you are deploying and how exactly to manage the deployment logic, what phases to run, and how to determine success or failure. Our entity model is built to allow quick enablement and smart Canary deployments from zero to production within the same day. It includes guided setup, validations, and checkpoints to make sure that you have correctly defined your strategy. Second, in many cases, a linear improvement requires an exponential effort, which is quite absurd. You ask to upgrade your deployment pipelines and getting lost between multiple services and imperative phases. OceanCD Canary mechanism can be easily customized, reused over services, and manipulated by the user. This is one of the most important capabilities for organizations that run multiple pipelines for tens to hundreds of services, because it saves tons of time on changes that can be easily implemented across environments and services with OceanCD. OceanCD provides a friendly visibility to service owners and software developers that get for the first time a tool that eliminates the CD black box paradigm and allow them to get decisions, of course, conclusions, or even automate them, which is a significant advantage compared to other tools. And last but not least, the process is verification-oriented. This means verifications that actually navigates the process and automatic actions that are being taken accordingly based on your strategy definitions like rollbacks or interventions with manual guardrails. So I think that we talked a lot on OceanCD and the problem it solves. So I think now it's probably the best time to see the product live in action. So let's go to the live demo. Let me just share my screen. All right then. So what you see over here is the Spot console, and actually you see OceanCD is part of the Spot console. And our journey basically starts in the settings area, because the first thing that you need to do in order to start working with OceanCD is to add a cluster. Now, adding a cluster means installing OceanCD operator inside the cluster in order to allow OceanCD SaaS to manage the logic. Reminding you, OceanCD is a multi-cluster product, which means any Kubernetes flavor. This can be COPS, EKS, AKS, GKE, even an on-premise Kubernetes cluster, as long as it has a network open to the OceanCD SaaS, it can be managed from one place by OceanCD. It is quite easy to add a cluster. You can do it through YAML or through Helm installation. The only thing that you need to do is to provide an identifier to the cluster, your Spot API token, of course, to say if Argo Rollout is already installed or not in the cluster, because we are also utilizing Argo Rollout behind scenes. And basically, from this point, the only thing that you need to do is to run the Helm commands. If you want, you can also edit the values the way you want to edit it. And basically, that's it. Within 60 seconds, you will be able to see your cluster being added part of the list over here. And the first thing that we are going to do is to map all the workloads that are included as part of the cluster. Now, the benefit here is basically double. The first thing, you can see all the workloads, all the live images, as also the pod's readiness, which means readiness from applicative perspective, readiness to receive network. But one more thing that you can do also through this view is to take your deployments and migrate them to be Spot deployment. Spot deployment is basically an OceanCD custom resource that we are using in order to allow OceanCD operator to manage the services. The only thing that we are doing is duplicating the deployment, and assuming you are satisfied with it, you can run all your services using a Spot deployment without the deployment. That means that you can remove the deployment from your Git repo and decrease the replica sets to 0 in the cluster. But we are not doing this automatically. To start with, in order to allow you to test the product, we are just duplicating the deployment and creating the CRD, the Spot deployment. So basically, what I'm going to do right now, I'm going to show you a quick migration process of one of the deployments in one of the connected clusters. Let's take, for example, this one. What I'm going to start is a 3-steps migration process. The first will be to generate the Spot deployment, which is basically changing the kind of the deployment into Spot deployment and the API version. We are going to create a strategy that will be the actual logic that tells OceanCD once Spot deployment is applied to the cluster, how exactly to navigate it, what are the verifications, what are the tests, how to split the traffic between the Canary version and the stable version. And at the end, we are going to connect between the strategy and the Spot deployment using the rollout spec. As you can see, what we have here is the manifest. That the only thing that you need to do basically is to copy it and apply it in your cluster, creating the Spot deployment resource, the Spot deployment CRD. The next step will be creating a strategy. We are not going to do right now something that is too complicated. Basically, I'm going to create a strategy based on a couple of phases in which I'm going to navigate some of the traffic to the Canary deployment, some of the traffic to the stable deployment. I'm going to increase it step by step. I'm going to add manual pauses to allow me to test the version both internally and with my monitoring tools. Basically, I have a predefined strategy. The only thing that I need to do is to change the name. Oh, sorry, let's click on the edit mode, of course. Notice that in this phase, you don't need to copy a thing. Basically, it's being applied directly to OceanCD SaaS once you click on Next. And the next phase will be, as we said, to bind the strategy together with the spot deployment, together with the service. I will also change the name of the rollout stack. As you can see, everything basically is with templates. Everything can be easily editable through the UI. And the cool thing is that you can also add, in case you're using one of the popular traffic managers, it is built in. So the only thing you need to do, assuming it is installed in your cluster, is to define what is the traffic manager that you're using. I personally love to use Istio. I'm using it in the subset level. I will click in Create. By the way, at each step, if there is a problem, if there is any conflict that is related with the definitions, with the references, maybe with even phrases that makes no sense, you will receive a validation error, also instructing you what exactly you should do, which is also something quite impressive because I don't think that there are tools today that are actually guiding you hand by hand till you are getting the Canary deployment. Everything's okay. I will go back to the settings and I can see basically that the new rollout spec has been created. I can see also that the new strategy has been created together with many other strategies. And to remind you, these strategies are basically reusable. That means that you don't need actually to define a new strategy each time. You can take an existing strategy and use it for each service that you're deploying, which is also a great advantage comparing to other tools because we are providing a reusable mechanism that saves tons of time. What I'm going to do right now live together with you, I'm going to take one of my applications. Actually, I called it Istio Spot Deployment application because I'm using Istio. I'm going to apply a change, which is a new image. Let's do it live in the Kubernetes cluster. Configured. And the immediate thing you're going to see is that a new rollout was added into the process. Basically, what we're looking at right now is the rollout dashboard that includes all the rollouts into all the clusters that are connected to OceanCD for all the services that has defined that they are being managed by OceanCD. You see different metrics that are related with rollout durations, rollouts that your attention is needed in order to take a look, rollbacks, successful rollouts. Everything can be filtered. Everything can be categorized based on specific namespace or based on specific rollout spec. Let's say, for example, my namespace, Amir Rollout. You will be able to see the rollout that I'm running right now, as also all the metrics that are being updated. You can also play with the time definition. And what I'm going to do right now, I'm going to log into the actual Canary deployment process. Now, this is something huge because we are providing a really abstract view for any stakeholder in order to understand what's going on. At the moment, I'm running a 4-phase strategy. 5% are being navigated to the Canary deployment, as you can see, both from infrastructure perspective, as also from the version deployment. You can see the Kubernetes events, the Kubernetes resources changes, the differentiation between the old desired state and the new desired state. As you can see over here, I'm switching between the versions. And since I've defined a manual pause, which is, again, absolutely something that I can define by myself, this can be also fully automated from the start till the end. I will choose to promote. to the next phase. And basically, actions are allowed also from here, from those three dots. You can promote, you can jump to the last phase, you can roll back, you can pause the rollout, you can retry in case of failure. And let's say right now, also in the second phase, when 25% is being navigated to my deployment, let's say that I have an issue. Let's say that I'm looking on my monitoring tools, like Grafana, for example, and I see that there is an increase that is abnormal with the CPU usage, or maybe with the memory. Anything that looks suspicious, okay, maybe I will roll back to the previous version because something is not acting as expected. So the only thing that I will need to do is to click on roll back over here. And basically, starting this moment, a rollback process is being initiated, as you can see over here, which means we are taking the 25% of traffic that was navigated to the new version, and we are taking them back to the old version, to the stable version. And this is something that we could see based on the metrics. And as I will show you in a second, this is something that is going to be also fully integrated as part of the Ocean CD rollout process. By the way, during the whole process, you can see also the rollout spec, you can see the strategy YAML, and you can see also the infrastructure as it's being updated over here, the resources that are being changed, the Canary version that is being deprecated, and the stable version, which basically going to be the last version that is going to stay, and all the 100%, as you can see over here, right now are being navigated back to the stable version. I will go back to the rollout table, and as you can see, the last try to do a rollout of an updated version has been completed with the rollback to the stable version, which is still the live version, as you can see here, version 21.3. And basically, that's a full demo of the capabilities of Ocean CD as are already existing in our production environment. Customers are using it as part of the version that we have released in the last 2 weeks. Let me stop sharing the screen and we'll go back to the presentation. Okay, cool. So the one thing that you haven't seen yet in the console, and this is something that we are adding like in the upcoming weeks, we are going to add a significant addition that is our continuous verification templates. Ocean CD continuous verification logic is being added through our SaaS and allows real control and understanding of the application state in production. The most popular monitoring tools are supported, and once installed in your cluster, they can be easily integrated to Ocean CD strategy and automatically navigate the deployment process, but yet in a super controlled manner. For example, what you see over here is a 5-phase strategy that we are at the moment in the second phase that includes verifications taken from 5 metrics and 2 different tools, Prometheus and Datadog in this example. So instead of jumping between multiple monitoring tools and Kubernetes events, I can see it all in one place, and I can see exactly how it navigates the process. Now, what you see over here is a query that calculates the average CPU usage of the Canary version. And what you see over here is, of course, also visualization of the charts and comparisons between the Canary version and the stable version. And this is a really cool performance feature that we call it baselines. And as you can see, it's really super intuitive to understand what's going on and what are the exact gaps between the performance of the baseline version, the stable version, and the Canary version. Now, the idea is to allow the verification metrics to be part of the delivery process instead of multiple data sources to overview and get lost in between. And the UI language, as you can see, was built in a way that you don't need to have deep operational skills or waste time between multiple places in order to get a clear understanding of your service releases. And as you can see here, you can get also the data with a nice summary view based on timestamps and dive into specific phases or Kubernetes events during or following the rollout spec process. And this is also something that is important to emphasize. Everything is being kept in OceanCD SaaS. So you have a complete change management log of everything that happens, when exactly it happened, what happened, who triggered it, which is also something quite nice for both enterprise and startup organizations. Now, OceanCD was built to provide a solution for each of the stakeholders that are part of a continuous delivery process, which is not only the DevOps engineers. We mapped the potential users and what each most interested with, but not necessarily get with the existing alternatives. And as simple this sketch is, it describes quite good who are the stakeholders and what each told us that is most interested with. The developer wants more understanding around what's going on with his releases. The DevOps engineers ask for a product that can provide more safe automations based on metrics. And SREs, of course, wants to monitor in real-time production environments, see the changes, and investigate critical events. And what OceanCD does is to take all these themes and provide them in one place so all stakeholders has one source of truth for all of the requirements. OceanCD is a standalone solution, but one of its strengths is that it is also provided as part of the powerful Spot console that includes both continuous optimization solutions for infrastructure and now also a solution that provides structured delivery processes that you can easily implement for your application changes. And the cool thing is that since we are running also infrastructure optimization products like Spot Ocean, it means that you can get a multi-cloud solution for all of your Kubernetes needs in one place for both application layer and the infrastructure layer. And even more than that, having OceanCD together with our compute optimization, FinOps, big data, and SecOps offerings allows a complete CloudOps platform. And as we take care of both the infrastructure, the data flows, and the software delivery requirements. I think by that we can finish the session. I will just say again, OceanCD public beta is live, and it will be available for any organization that asks to use it. Just register in the link that Alex from our team will send in a minute in the chat. You can see it also in the slide. You can also connect directly to me or to Oleg Verkhovsky, our head of continuous delivery, our head of continuous delivery solution. Register, allow our product team to contact you, have a quick conversation on your unique requirements, and run POC together with our CD experts. Of course, early product adopters and customers that ask to be design partners will get exclusive benefits and will be able, of course, to have a great influence on new features that are better suited for their use case. Other than that, I think that we are good. I would like to thank you for joining us today. There is a lot more to come, a lot of cool features that we are actually adding day by day. I assume that tomorrow maybe this session will be in old news because we are also deploying, as we are talking, some new features using OceanCD, of course, as part of our internal architecture. So thank you. It was great. Feel free to contact us and have a great day. Thank you.